So let us start. This is the first lecture of topology. Well, actually we are starting with the topology part. Before that we have done some introductory lecture. So before going to topology of metric spaces, have you heard this word metric? Have you heard it? Maybe not. So let us go back and let us see. See, in your FYBSc, what did you do? What did we start with in FYBSc? We started learning with real number. Then what next? Once we know the real number, we try to find what are the different properties it follows. Then we defined something called as distance. Do you agree? We wanted to compare two things and something like that. Two real number if I want to compare, and then later on we came to the distance between two real number. And what was that? If you want to find the distance between two real number, what is that? Yes?
Mod of a minus.
Perfect, exactly. So we defined mod. Correct? Modulus, and we used to denote it by say mod x. Can you tell me what is the definition of mod x? Say x belongs to real number. What is mod x?
Maximum of x comma minus x.
Correct. Maximum of x comma minus x. Is there any other definition which you have done in your 12th standard? Yes? Mod x is, it was something like if your x is greater than or equal to 0, then the value of mod x is going to be same x, correct? And if your x is negative, then it is minus 6. Do you agree both the definition are same? Do you agree both the definition are same? Mod x is maximum, so that means same means what? In mathematics something is same, that means what? From here I can go here, and from here I can go here. Is that clear? So maybe I'll just give you exercise or homework for you, and try to prove this. From here go to here, from here go to here. So let us keep that here only. So here what did we do? We started with real number. We try to see some properties of mod, and what is mod, that is distance or something like that. Later on in your SYBSc, what did you do? Yes, in SYBSc you are not having R, you are having R2, R3, correct? So when do you want to find the distance between 2 points, what did you do? Yes, and suppose there are 2 points, say x1, y1 and x2, y2. If you want to find distance between them, what is distance between them? Say this is P and say this is Q. So what is distance of PQ? Yes, what? Yeah, but what is that? What is the value?
Under root
Under root
x2 minus x1 the whole square.
x2 minus x1 the whole square plus
Y2 minus y1 the whole square.
perfect. Is that clear? Just 1 second. Okay, so this was the distance. Now in R3, what is this distance called? This is called usual Euclidean space, in which distance is defined like this. But what I am trying to tell you here, that is, this is not the only way to find distance between 2 points. Say in R2, suppose let us draw. Yeah. So let us, you are having 2 points, correct? What is this distance? From the graph, what do you think, what is this distance actually? This is the smallest distance between P and Q. That means this is distance between this. And do you know how this formula came actually? Why this is square root of this and this? Do you have any idea about that?
Pythagoras theorem.
Exactly, Pythagoras theorem. So how will you apply?
Sir,
Correct? Something like this. So this is 90 degree. What is this distance from P to, let us say, intersection O? What is this distance PO? If you are having
x2
this,
minus x1.
correct, exactly, x2 minus x1. And what is this distance between QO? This is y2 minus y1, correct? Now if you want to find this distance, that is shortest distance from P to Q, so what is that? That is the straight line, correct, joining them. Do you agree? And you got this formula. But this is not the actual way, this is not the only way to find the distance between P and Q. Can you give me any other way to find distance? That means I want to go from P to Q. Do I have any other way? Yes, Neha? Do I have any other way to go from P to Q? Is the question clear?
Parallelogram law.
No, I don't want parallelogram law or anything. Can you give me any way I want to go from P to Q? That is the only question I am asking. Let me draw it in the next page so that just 1 second.
You can go from P to O and O to Q.
Exactly, correct. Think about some other way. Is there any other way?
P to origin and origin to Q.
Okay, I need answer from someone else. Sorry Shreyas, but I need answer from someone else. One answer is okay, that I am giving you, that is I can go from P to Q directly. Correct? Another answer Shreyas gave us, that I can go from P to O. He is telling, sir, let us go from P to O and then O to Q, correct? This is what you are saying, Shreyas?
Yes, sir.
Correct. Can somebody give me any other way? Is there any other way you can give me to go from P to Q? Payal,
Sir, we can take the curve path.
curve path, which curve? Can I go from here like this? Curve path. This is what you
Yes.
are saying.
Yes, sir.
Very good, Payal.
Yes.
Correct. That means what I am doing here, I am just making a circle. Maybe I am not able to draw the perfect circle or something. Just wait a second. Yeah. Let us understand. Sorry for the graph here. It looks quite odd, but let us understand. For understanding, it is okay. So what do you say, Payal? I can go from here, correct? I can go from here to here like this. Yes? Or else I can go from
Yes,
here
sir.
to here like this. So how many ways now I am having?
Infinite.
Yeah, but at least now I can see 3 ways. Do you see that? This is the first way. This is the second way you can take. Correct? And this is the third way. Yeah? Yes? Is that clear? Do you see something more? In the first way you are having straight line. In the second way you are having actually a, you can talk about something like rectangle, but it is half rectangle. In third way you are having a circle, but it is half circle, you can say semicircle. Is that okay? So the motto was to give this exercise is from P to Q I have so many ways. Correct? This is called metric. This is called distance between P and Q. I am having so many ways to go. So the question would be whether this other way they also satisfy the same condition, which was my usual distance was happening. Do you understand what I am saying? You can
Yes, sir.
you can understand like this. Whatever property mod was having, same I have extended to this distance formula. Correct? It should satisfy the same thing. Now my question is whether if I give any other way to define distance between P and Q, whether that also satisfy the same thing. That means if I change my orientation or something, distance will be same. If I change my position, distance will be same. Distance will not change. It is something like called translation invariant. Correct? So here you can see 3 different type of distance. So let us understand. Let us write the definition first. Then we'll go ahead. Is the diagram clear to you?
Yes.
Yeah, good. Let us write the definition first. Let X be a non-empty set. You can say X is not equal to empty. Let X is a non-empty set. A function D from X cross X to R. This is what is this X cross X? Do you understand this notation? How the element of this look like? How will the element look like of A cross B?
Ordered pair.
Yes, this is ordered pair. How will the element look like? Ritika,
x cross x comma x.
uh, not about this, I'm talking about this. Let me ask Ritika,
Yes, sir.
how will the element of A cross B look like? Yes, Payal,
A1 comma B1, A2 comma B2.
can I
Order
can I write A comma B where A belongs to B, correct?
A.
It cannot belong to B.
So A belongs to A.
Okay, yeah, this is what I wanted to hear. That is, the order is important here, correct? The first person belongs to this first guy and the second one belongs to the second guy. Okay, good. So I'm having a function D which is from x cross x. That means the element it will take something like x comma x, and it will give me the result in R. So this function is said to be metric or a distance function on x if it satisfies some property. If D properties, what is the first property? We have already done this in your TyBsc, if you remember. What is the first property? That is, distance between x and y is always greater than 0, correct? For all x comma y belongs to x. And in first property there was one more thing, that is, distance will be 0 only if, yes,
x is equal to y.
exactly, x is equal to y. When both the points are same, then distance is going to be 0. What is the second property? Distance between x y is same as distance between y x, correct? For all x comma y belongs to x. And what is the third? You know that, the third one, triangle inequality, correct? Distance between xz is less than equal to distance between xy plus distance between yz, correct?
Yes.
Do you see the third property graphically? Do you see that?
Yes, sir.
Say this is your x and say this is your z, correct? I want to find the distance between xz. Say this is this one. This is always going to be less than distance between xy and distance between yz. This is sometimes called taxi cab property, something like that. I'll come to it later on when we'll be doing that modulus one. So for now let us just understand like this. It is forming a triangle, and why this is called triangle inequality? Because distance between xz is always less than equal to distance between xy plus distance between yz. Correct? Okay, great. Now once we are done with this, that means if you are having any function satisfying following property, what you are going to say? This function is called metric, and the pair that is x comma d, the set along with this function I'm going to write it as a pair. This is called matrix space. Yes? Is the definition clear to everyone? What is matrix space here? Why it is called matrix space? Because I'm having a set, and there is a function defined on that set, and that function satisfies some property. So if there is any set you are given, and you are given any function, if that satisfy all these three property, I can call that set as matrix space. Yes?
Yes, sir.
Perfect. Now let us try to see some example. I have already started with distance about modulus function, correct? So the question would be whether the set, that is x, if I take as a real number. Let us go to the next page. If I take x as real number, can you give me a d such that it will satisfy that means it is a matrix space. Can you give me a d? Can you give me a metric?
Mod of x minus y.
Perfect. Mod of x minus y. Correct? Now what is the thing you have to do here? What is the question now? You have to see whether this function d which I am defining here, whether it satisfies all the three properties. Can you quickly check it? I'll give you 2 minutes. Check it and tell me. Check whether this d satisfy all the three properties which I have just now told you. Start with first one, second one, third one. Try to do.
Yes, sir, done.
Great. What about others? Go slow, try to see whether you can do that or not. Yes, Neha, Britika, Payal.
Yes, sir.
Yes, sir.
Yeah, is it done?
Yes.
You can just quickly raise your hand, everybody, if you have done. If you have any problem, then tell me. Shreyas,
Yes, sir.
whether you can see everybody raising their hand. Is there anyone who have not?
Everybody has raised their hands.
Okay, great. So let us start. Let us do it quickly, one by one. Who is going to tell me the first step? Okay. Neha,
Yes, sir.
yeah, tell me how can I check the first step? If I'm having x and y belongs to real number, how can you tell me whether the first property is satisfied by this function?
Sir, we can write mod of xy as x minus y if x is greater than y and is equal to y minus x if y is greater than x and is equal to 0 if x is equal to y. That is, d of xy is greater than 0 in this case. And if we are taking mod of xy is equal to 0, then we use the absolute value definition and we can show that x is equal to y.
Exactly, good. You are using the property of mod here, correct?
Yes, sir.
So d of xy is equal to mod of x minus y. What did she do? You can just write it in the form of, that is maximum of x minus y comma y minus x, correct? Or you can write it in the set form, whatever Neha told you. That is, if x is less than y, so it will be x minus, but it will be y minus x. If y is greater than x, then it will be, sorry, I think I made a mistake. If x is less than y, it is going to be y minus x. If y is less than x, then it is going to be x minus y, correct? And they are going to be 0 if both are equal. So both the thing is true here. That means from this, I can already told you that I can say x minus y is always positive. So d of xy is always positive. And d of xy, if I take equal to 0, that means what? Mod of x minus y is 0, correct? Mod of x minus y is 0, that means what? Maximum of these two people is 0. When this is true, because I am taking maximum, when this is true, it will be only possible if your x is equal to y. And I can go back here. If x is equal to y, mod of x minus y is 0, I can go back. Is that clear? Since it was if and only if, that's why I am doing this. Is that clear to you, everyone?
Yes, sir.
Second property, Ritika, can you do that? Second property. What is the second property? You have to see.
X comma y is equal to b y.
Can you quickly see that? What is d of x comma y? It is mod of x minus y. What next? What should I write?
D of y comma x is equal to mod of y minus x.
So you want me to write d comma y, d of y comma x, that is y minus x. How can you say both are same? Yes, how can you say both are same?
From the definition.
From the definition of modulus function, exactly. Yes, what can you do actually? You can write this as,
Maximum of x.
yeah, you can do that also, but if you want, you can take minus outside. Can you do that? I'll be having y minus x, correct? Now what is this? It is maximum of this comma y minus x, which is same as mod of y minus x. Is that clear?
Yes, sir.
Good. Third property, who is going to tell me third property? How will you prove? Do you know something? Triangle inequality we have already proved in the case of real. Yes?
Yes, sir.
Yes, sir.
We know that mod of x plus y is always less than equal to mod x plus mod y, correct? And how did you prove? Do you remember that? Do you remember the proof of triangle inequality? You can do it by taking some cases or whatever you want. Both positive, both negative, one positive, one negative, you can do that. correct? If you know this, then can you quickly say about d of xy? What should I write? D of xy is xz, no, sorry, I'm taking xz. So d of xy is, this is x minus z. Shreyas, what should I do next?
X x plus y minus y minus z.
That means you want me to tell, you want me to add and subtract y, correct?
Yes, sir.
Is that clear? What next?
Triangle inequality.
Exactly, triangle. So this is going to be less than equal to mod of x minus y plus mod of y minus z. But what is this thing? What is this? This is distance between dxy, and this is distance between y and z. Correct? So you have proved d of xz, that is less than equal to d of xy plus d of yz. Good. So what can you conclude?
R is a metric space.
Correct. R is a metric space with the distance function mod. Correct? Good. So suppose you are having